All right, so let's practice balancing some equations. So remember what balancing means is you want to try to have the same number of each type of atom on both sides. And so it's about comparing, and then when they're not the same, it's about figuring out what you could multiply the element, what number you could multiply it by to make them equal. So I often teach this using a chart. The chart is not required. If you get better at it and you don't need a chart, you don't have to write it. Or if you find a different way that helps you kind of keep track of what you're doing, that's okay too. The other thing that I do is I balance in an order where I balance the metals in the formulas first, then any nonmetal that's not hydrogen and oxygen, then hydrogen and oxygen last. I would say about 85% of the time, this order gets me to the answer the quickest. But the order you balance is not really important. You have to go through the same process no matter what the order. So don't get hung up on the order that you're balancing the elements. Now, another important thing, and I will do this so you'll see, is you only look at one element at a time. Don't count everything before you start. Just start with the first element and only focus on it and then move to the next one. And if something you do in a step changes a previous step, then go back and fix it and keep going. So on this one, let's count barium first. So there's 1 barium on the reactant side and 3 barium on the product side. So to get them equal, I would multiply by the number 3, so on the reactant side, so they'd both have 3. And so that number that you're multiplying by, that's the coefficient. That's how you figure it out. And then where you place it, you cannot add any subscripts because that has to do with what the chemical is, so we can't change the formulas. You can't squeeze the coefficient between elements in a specific formula. The only place we get to put a coefficient is in front of a formula. So I would put the 3 on the reactant side in front of the formula with the barium, since that's what I was balancing. So now my bariums are okay. And so now I'd go to my sodiums and I see there's 3 on the reactant side and only 1 on the product side. So then I would think to myself, or I write it down, okay, so I'd multiply by 3 on the product side to get 3 on both sides. Then I would place that 3 as the coefficient, okay, in front of the sodium hydroxide because we're balancing sodium. All right, so now I will go to the phosphorus. So here's a phosphorus there next to the sodium. There's only 1. The 4 is connected with the oxygen, and since there's not a parentheses, it does not impact the phosphorus on this side. But on the product side, there's my 1 phosphorus in the formula, but there's a 2 outside the parentheses, so there's actually 2 phosphorus. So then I would go and multiply the 1 on the reactant by 2, so I could have 2 on both sides, and that 2 becomes a coefficient. Now, I cannot write it directly in front of the phosphorus. I can only put coefficients in front of the formula, so I put the 2 in front of the sodium. Now, this changes something I've already done, right? Because I thought there were 3 sodiums, which there were when I started. So now I have to go back. Now I put a 2 in front of it, so there's actually 6 sodiums now, right? Because there's the coefficient 2 and then times the 3. So now I look at my reactant side, my product side, and I'm like, okay, I got to change it. So I'm going to erase what I did previously, and I'm going to erase the 3. It can't be a 3. Okay, so I'm going to take that away, and I go back, there's 1, and so then I think to myself, okay, I need 6 now. I have 6, so I'm going to multiply it by 6 now. I had to change it. I had to correct it. So now there's 6, so I'm changing it to a 6, and that's totally allowed. So now, if you just look at it, just pause and look, I have 3 barium on the reactant side and 3 on the product side. That's still good. I now have 6 sodium on the reactant side and 6 sodium on the product side. Still good. I have 2 phosphorus on the product side on the reactant side, and 2 phosphorus on the product side. So now I've got everybody up to date now. So barium, sodium, and phosphorus are okay. So now let's look at the hydrogen. So hydrogen, I see here in barium hydroxide, there it is. Well, there's 2 in the formula, but I have a 3, so there's 6. On the product side, there's only 1 in that formula, but once you put a coefficient, it multiplies through all the elements, so there's 6. So I don't have to do anything. Now let's do the oxygens. So on the reactant side, I see there's 2 in this formula, 2 times the 1, but then times 3 again. So there's 6 from the first formula, and on the second formula, there's 4 in the formula, but I have to multiply it by 2 because I put a coefficient, so there's 8. And then I do the same thing on the product side. There's 4 oxygen times 2. There's no coefficient here, so I don't multiply by, it's just 1. So that's 8. And then there are 1 oxygen here, but I have to multiply it by 6. And so then there's 14. So my coefficients that I added, I put a 3 in front of the barium hydroxide, a 2 in front of the sodium phosphate. There's no number here, which would be a 1, and then this is a 6. So I don't have to write the 1, but that's what that number would be. Now, I do want to show you one other thing. If you've been practicing your polyatomic ions, then you might notice that like the hydroxide, OH, is on both sides, and the phosphate, the PO4, is on both sides. In single and double replacement reactions, the polyatomic ions just switch partners. And so when we balance, we can do them together. So here I rewrote it, and I'm going to start out the same way. But now, instead of balancing everything separately, I'm going to balance the hydroxide as a group and the phosphate as a group. This saves a step, and sometimes it makes it seem easier, especially if you've been practicing the polyatomic ions. So let's practice. So here there's 1 barium. We do the same thing, and 3. So then I'd say times 3. That would give me my 3. Then I would do the sodium. There's 3, and we know that this messes up, but we're going to work through it again. And there's 1. So if I was balancing, I'd say times 3, and I'd put a 3. Because that's what I'm multiplying by. That's how we know. Then I would do my OH. So on this side, here's OH, and there's 2 of them. So there's actually 6 because I already put the coefficient there. On this side, I have 3 OHs. Now, when I look at this, I can't. So this, I can't, like it doesn't, the NAs don't, like to get 6 on both sides, this number would have to be a 6. So then I'd think, okay, well, I've got to change it. And the only way to change it was to make this number a 6. Like I have to change that. So, because what I have is, I had 3, but now I don't have 3. If I take it away, I have 1, and I have to multiply it by 6. Now, just like before, this changes my sodium. So now I'm like, oh, great. Now I've got 6 sodium. So I come back. I see I have 3. So I'm going to say times 2. and that gives me 6. So again, sometimes you have to go back and forth a little bit. Okay, now let's do our phosphates. So it's 2 phosphates times, there's only 1 there, so I have 2 on this side, and I have 2 on this side, so it's balanced. So again, you may use the polyatomic ions if they're in a group on both sides to balance them. Okay, it's just practice. And this is a hard example because it does make us go back and fix the sodium, and we have to take away a coefficient we added and change it. So it does make it hard. Well, let's take a look at E and F. So here is letter E. All right, so how would we start? Again, I compare, and I'm going to do the metal. So I do iron and cadmium. Now look, you could do NO3 together. How do I know? Because there's an NO3 on this side and an NO3. I think I wrote this wrong. Did I write it wrong? Is this supposed to be a 3? I bet it is. Let me go check. Okay, I did check, and I made a mistake. This is when I wrote it the first time. This is a 3. I was like, it's balanced, but that's a 3. I remember when I looked at it, I was out. Okay, so you could balance, and I think this is a really good example to keep those together. Do you see how they're together in parentheses? Let's keep them together. All right, so first I'm going to do my Fe. So there's 1 and 1. Do nothing. Then I do my cadmium. There's 1 and 1. Do nothing. Now I do my nitrates. Here's the nitrate. When you have a polyatomic ion and there's more than 1, they put a parentheses. So there's 2 on this side. Here's my nitrate. When you have more than 1, they put a parentheses, and there's 3 on this side. So the first number that 2 and 3 have in common is 6. So if I multiply this one by 3, I will get 6. So that is my coefficient, and it has to go all the way in front of the cadmium, okay, because it can't go anywhere. Like, it has to only go in front of the formula, not in between, not changing coefficients. And then on the product side, I have 3, so this one I'd multiply by 2. So that's my coefficient. I put a 2. Now, when I do that, I changed my iron and my cadmium. So let's go back to my iron. So now I still have 1 on the reactant side, but now because of this, I multiply. So this side has 2. So then what I would do is multiply this side by 2. That's my coefficient, and the 2 goes in front of the iron there. So now I have 2 irons on both sides. And now we're going to do the same thing with the cadmium. Now, on the reactant side, because I added the coefficient, I have 3, but I still only have 1 on the product side, so I'm going to multiply this one by 3, and what you multiply by is the coefficient, and so then I have a 3. So my coefficients are a 2 in front of the iron. I have 2 irons on both sides. And 3 in front of the cadmium makes 3 cadmiums on both sides. And then I have 6 nitrates and 6 nitrates. Now, if you want to practice this, breaking down the nitrogen and then the oxygen, you will do the same thing and come up with the same answer. All right, let's do this last one, the F. Now this one, I'm not going to do anything with polyatomic ions. I don't see they didn't stay together. This is a decomposition reaction. So let's see, I have iron, and then I have carbon, and I have oxygens. So I have 2 iron on both sides. So that's good. Don't have to do anything. I have 3 carbon on this side and only 1 on this side. So let's give it a go. Let's see, I'd multiply by 3. All right. Now the oxygen, which might cause us some trouble. Let's see what we got. Let's see. So there's 9. Oh, I already feel like there's trouble. There's 9 on this side. 3 times 3. Oh, no, we're okay. There's 3 on this side. And then 3 times 2 plus 6. Oh, okay. I was expecting a little more drama. But so to balance that one, all we needed to do was put a 3 in front of the carbon dioxide. So then evaluating it, we have 2 iron on the both reactant and product side. I see 3 carbon on the reactant side, and because I put the 3 carbon on the product side. I see 9 oxygens on the reactant side, because 3 times 3. Then on the product side, I see 3 oxygens in the first one, and I add that to 6 oxygens on the second one. And so it's balanced. Balancing does take practice. My biggest word of advice is try to think about one element at a time. And then remember, you can only put numbers in front of the formulas of a compound. That's the only place the numbers get to go. Nothing else gets to change in the formula. Okay, good luck.